Welcome to solverfy.
Question number 103 is a complex ion formation equilibrium question, and using the equilibrium constant for the formation of the complex ion of zinc with cyanide, you should be able to determine the concentrations of zinc, the complex ion, and cyanide once equilibrium has been established. To do this, we need to know what equilibrium we're considering. It's zinc 2 plus 4 cyanides going to our product, which is the complex ion. It has a Kf value then that will be equal to the complex ion concentration divided by the zinc concentration divided by the cyanide concentration raised to the fourth power because of the coefficient 4. This has a value given to us in the problem of 4.2 times 10 to the 19. We can determine the zinc concentration by recognizing that zinc is being provided into the solution as zinc chloride. Zinc chloride is soluble according to the solubility rules, so it will completely dissociate. So if we take 0.84 grams of zinc chloride and we divide by the molar mass of zinc chloride, that will tell us the moles of zinc chloride that we have added to the solution before this reaction occurs. We then can divide that by the the volume of the solution, which was given to us as 245 milliliters, or 0.25 liters. Then, when the reaction occurs, some of this zinc is going to be consumed. We don't know how much, so we'll just say minus X. Finishing this calculation gives us the zinc concentration at equilibrium will be equal to the concentration of zinc before the equilibrium occurs minus the shift that occurs to reach equilibrium. We can do something similar with cyanide. In the case of cyanide, we had an original concentration of 0.150 molar sodium cyanide, which was given to us. When this is consumed, for every 1 zinc, we need 4 cyanides. So the change in concentration of the cyanide will be minus 4x instead of just minus x. Then the complex ion concentration will be equal to x. If this decreases by x and this decreases by 4x, according to the stoichiometry, this should increase by x. So what we're going to assume first is that all of the zinc is initially consumed in order to make the maximum amount of product. And the maximum amount of product can then be determined by the concentration, the initial concentration of zinc. The initial concentration of zinc, which was calculated with this right here, is 0.02516. We will assume that once equilibrium has been reached, all of our zinc has become the complex ion, so now the complex ion at equilibrium has the concentration that zinc had before equilibrium was reached. Then we recognize that this value is our x value. So the cyanide concentration can then be calculated by taking the initial cyanide concentration minus 4x, 4 times the concentration of the complex ion that was formed. And this gives us 0.0494. So now we've solved for 2 concentrations at equilibrium, the complex ion and the cyanide. But it also wants us to solve for the concentration of zinc 2 plus at equilibrium. And to do that, we now have to resort to the Kf expression. We made the assumption up here that the zinc is going to be consumed completely and that our x value is 0.02516, so this would be calculated using this equation as 0, but we can't have a 0 value in our equilibrium in order to have the equilibrium expression equal to 4.2 times 10 to the 19. So to solve for the zinc concentration, we need the Kf expression. If we rearrange this expression up here, then zinc will be equal to the complex ion concentration divided by Kf divided by the cyanide concentration raised to the fourth power. We know the complex ion concentration. We just calculated it here. We know the Kf value. It was given to us here. And we know the cyanide concentration. We just calculated it here. We'll make sure we raise that cyanide concentration to the fourth power. This will then give us a zinc concentration of 1.01 times 10 to the negative 16, not 0, really close to 0, really small, but not 0 because an equilibrium has been established. So the equilibrium concentrations for the three species that are requested are shown here encircled in green.